Hi everybody. Before we understand about Java programming, let's look at why we have to learn Java and what is the importance of Java in the current world. First of all, a very warm welcome to the Core Java course, and we are very excited to teach you about various exciting features of Java which help you to be like very good in Java and you can advance your career from there. So if you look at from various websites which do a survey on these programming languages where they will tell you which programming language is used across the world. If you look at TUBE is one of the one where actually they conduct survey across and identify which programming languages are top, and as per them in the 15th consecutive year Java is considered as one of the number one programming language. Another thing is, if you look at Oracle blocks, approximately 10 million developers and 7 billion devices worldwide uses Java. And as you know, when we say devices, why Java being used on devices? Because it's platform independent. So what exactly is platform independent? So here, platform independent means platform here indicates operating system. That means whether you're working on a Windows operating system or Mac or Unix or any other operating system, it doesn't matter. If you have JVM installed, it will work seamlessly there. That means you go and have a code which is executed on a particular operating system like Windows, and the same code you can, once you compile it, you can take and execute in a Mac operating system also. So that's a part of Java, since it can have this kind of platform independency across multiple operating systems. You can run even on devices as well. Now, Java is like very versatile. When we say that it is more of a, I would call it as a, even though it is a platform independent language and adopted mostly on web and mobiles, I would consider it to be like a very versatile. The reason is like it is not fixed to one particular domain. If you look at earlier programming languages like Fortran or Basic or COBOL, they are all focused on one particular domain. Even MATLAB, which you hear now and then in Coursera, whenever people teach ML and all, those are like actually made to solve one set of problems. Like MATLAB is completely on the scientific and numerical applications, whereas Fortran is similarly on those lines, and COBOL is for business applications. So like these are actually biased towards solving one set of problem. But if you look at Java, it can be used on any set of problems. Like it can be used on web, mobile, desktops, using different operating systems or platforms. It can be used on IoT, and it can be used to have something like an API mechanism. REST APIs you can easily build using Java, and you can have your client calling them. It can also be used in big data. In fact, I'm not sure whether you know the Hadoop, which is one of the powerful component of big data, which actually help you to parallelly process the data. The entire MapReduce of Hadoop is written in Java. And coming to e-commerce, I'm not sure whether you are aware, all the Amazon website which is running is actually written in Java, because Java supports object-oriented programming language, which actually helps it to helps the programmers to maintain their code or to maintain their projects for a longer time in a more modular fashion, scalable and better modular, or to make it more extensible, debuggable. I mean, you can look at like multiple ways, and it actually helps the language to be more reusable also, so that only when somebody builds at the initial time, it might take some time. That's where actually takes more time, but once it has come to a stage, after that any kind of extension of the language, it can be easily done. So that's the reason why a lot of people build use Java for their projects which are sustainable for years, because Java is made for that. And all these high frequency financial trading platforms, if you look at their backend, it is written in Java. And scientific applications, if you ever look at websites which do a lot of scientific applications, if you look at 100 websites, I'm sure that 20% of the websites backend is written in Java. It is like that. All the scientific I'm talking about, whether you take weather.com, which is a website which gives you weather information, and there are certain websites which talks about scientific related stuff like Fourier transformation and all that. Those are all actually the backend was managed by Java itself. And I've just called a few. If you look at, there are much more like that. Now, Java, like I said earlier, if you remember, I said like it is used on mobiles also, and one of the powerful operating system on mobile is Android, and Java in fact powers Android also. And in fact, your Gmail, the it's actually like most of the Gmail is built in Java, and it is in the Curiosity rover on Mars as well. Now, who are all using? Like I already mentioned, Amazon using it. LinkedIn was most of the LinkedIn stuff is built in Java. eBay, Netflix, Slack, Android, Spotify, Google, Capital One. Here, if you see, a lot of them are mentioned. And in fact, if you look at, there are a lot of other things are startups. Like I was working on a startup called Bloomreach. In fact, most of the system is built in Java. Earlier, they used to write a lot of, this Perl or Python coding. They have migrated a lot of their code into Java and Scala. So these two are basic, one of the powerful object-oriented programming languages. So like you take any particular platform, pick any particular company where it is running for years and years, and look at their backend. I'm very sure that they will be using one of the object-oriented programming languages, and in that, if you count down the number, Java will be the highest being used. And as you know, since the Java is in more demand, the average salary of the professionals who work or who know Java is something around 50 to 100K dollars. And in this course, if you look at, we will learn about core Java. So when I say core Java, if you look at Java, it is actually like there is 3 parts to it at a high level. If you look at, there is this core Java, advanced Java, and enterprise edition Java. So core Java completely talks about the foundational structure which actually you need so that you can program in Java. Whereas advanced Java talks about even how to do remote method invocation, how to do database connectivity, or how to do something like on the web, how to create web pages using Java and do something like a request server model. All that which is beyond just programming in your system, something connecting to external will come under the advanced Java part. When it comes to enterprise Java, it's more about how you actually build things in an enterprise platforms. All that will come under there. So you will learn a lot of theory here as well as a lot of hands-on demos and quizzes so that you can assess whether your knowledge is up to mark or you need to work on to improve it. And if you're a college fresher or new to this Java developer role, this course will definitely help you to kickstart and start writing programs in Java and start enjoy the exciting features offered by Java. Now, if you look at this entire course is divided into 7 modules, or I would call it as 7 lessons. The first lesson completely talks about what is Java, why we need to learn about it, and what are the different OOPS concepts here. And we are talking about Java 11 specifically in this entire course because that's the latest. So that's why it's mentioned as Java 11 introduction. Coming to utility packages and inheritance, we are going to talk about what are the utility packages you can use in Java. And we will give some examples on how to use them. And at the same time, we will show them where and all inheritance is used and how it is very powerful when you actually work in Java programs. Now coming to lesson 3, we talk about something called multi-threading. So you might have heard these terms called multi-processing, multi-threading and all. All of these particular things are existing in order to achieve something called parallelism or concurrent execution. That means if you want to execute multiple tasks at the same time, these are your answers. So in Java supports multi-threading. Using that, what we can do is at the same time, you can have multiple functions executing at the same time. So if you ever work on a Windows operating system, you might have opened a browser, you might have played a YouTube, you might have played a movie. How you think that given that you have only one processor in your computer, they are all running parallelly. They are all run with the concepts behind, with the concepts like operating system concepts like multi-processing or multi-threading internally. In fact, your browser runs multiple tabs in your computer by using this multi-threading concept. All that how to implement is what we learn here. Now coming to debugging. Debugging is a very important aspect not only in Java, in every programming language, where whenever you code in your production system where it is running 24/7, how you ensure that it's all runs without any issues, and what if there is a problem? How do you identify that problem? How do you debug it? Or when there is a problem, how do you quickly detect it? Or how do you alarm on it? All that is going to learn here in the debugging, where actually the recommendation is to write into different log files. When I say log file, it is nothing but a file where every activity of your system will get logged so that you actually go and check what is happening. That is to help to detect the bugs in your system. And not only that, in case if there is anything alarming, when I say alarming, something like your system is getting into a lot of error situations or your system is getting high latency. That means the request a client is sending, but the response you are getting is, let's say, 2 minutes, 3 minutes, which is huge on a live platform. all that you can detect and alarm on it using these debugging techniques. And one of the debugging technique we are going to learn here is how to do that in Java using log4j. Now coming to the lesson 5, which is called JUnit. JUnit is one of the popular package in Java. It is meant to do some kind of unit testing in Java. So when I say unit test, it's very important that every developer today, earlier was the case that where developer roles and testing roles are separate, but if you look at all the product companies, all product companies encourage developers to write a basic test cases which are called unit test cases. Unit test cases are nothing but for each of the functions you write in your code, you again write the test cases to see whether they are actually performing as expected. If they are not performing, how should we catch it and fix it? It actually helps you to make your code stronger by identifying all the edge cases and make your code more performant enough. And that's the reason every code, when you send for any peer review, when I say peer review, reviewing with your colleagues, it is very important that that gets reviewed properly. So that's where this JUnit helps in writing these kind of unit test cases. Now coming to Java cryptographic extensions. So cryptography is more about science where actually you deal with different encryption techniques to convert a plain text into some form which is not easily understandable. And here in Java, we are going to learn about two algorithms called Poly 1305 and Cha-Cha 20. I mean, the name looks funny, but yeah, those are the names and one of the popular algorithms. They actually help you to convert the data in a form where it is not easily understandable. At the same time, the Poly algorithm, which is mainly needed to identify if the right user is authenticated or if the right information is properly sent without any intrusion in between. Now finally, the last chapter, design patterns, is one of the powerful concepts. This design patterns is not specific to Java. Even the same concept can be implemented in any programming language. But this concept talks about when you are building a project, what are the different approaches you can take so that you can build your project more better. Like let's say, for example, it's not like, if I ask you, like, can you please develop a system where a small HTML page, a very small website you want to do it, where it just shows the clock in your system, in your computer. Now what you have to do, you have to first of all fetch the clock, or first of all fetch the time in your computer and send it to HTML, and HTML has to generate. So that if it looks simple, there are different ways to doing it. But if you really look at the way to solve it is you have to first divide the code into one for backend, one for front end. If you want, you can have something called a middleware also in between. You might be thinking like, just for simple thing, why I have to do that? Always think big. What I would suggest is, even though it is small here, when you actually have that perception of building things big, you better divide the code now itself. When you start smaller, you can always do the same thing even when you build bigger projects. This might look very funny for small projects, but for big projects, this really makes a lot of sense because you have code properly manageable. And whatever the structure I have said now, that structure is called model view controller, and it is one of the design pattern. So design pattern tells about how you build a bigger projects using some of the approaches so that they are more maintainable, better modular, and at the same time, how can you make it more extensible or reusable? That's what it talks about.